Real quick video here on how to enter in piecewise functions in your graphing calculators. The calculator that I use in my class and my students use are generally TI-84 plus, but I think this method will work also for 83s and 82s as well. The first thing you want to do, and this isn't always necessary, but I think especially on the older models, you have to get your calculator into dot mode. So you press mode and you go down to where it says connected or dot, get it into dot. And then you just go over here and you type in your function, right? And the syntax is the most important part. You have to, in parentheses, put your function piece, and then over here you put your constraint in parentheses. Go down to y sub 2 and put your second piece, and in parentheses put your second constraint. And you graph it. So you can see here, what you're looking at is this is the linear function y sub 2, and right here the graph jumps up when x is 1, the y value jumps up to 4. So that's 1 comma 4. All right, a little bit more complicated example right here. If your first function piece is sine of x, and that's defined when x is less than or equal to 1, you type in sine of x in parentheses, and you open another set of parentheses and you put your constraint, x is less than or equal to 1. All right, and this less than or equal to sign is in the test menu. And the test menu, if I go to my calculator here, the test menu is, go back to my home screen, is second math. Math key is right here. All right, and you can see all of your, not only your equal sign, but your inequalities as well. All right, so then we go to our second function piece, 0.2x squared minus 3. That's defined when x is greater than 2. And then if I graph it, you can see that here I've got my sine of x, and over here I've got my parabola. All right, and they're split up in here, right? This is sort of like a barrier. Let me draw that a little bit better. Let me get rid of these two. This is sort of like our barrier, right? That's the line x equals 1. And then the graph jumps over to x equals 2, which is right here. And there's nothing defined in between them. All right, and that's sort of the basics of entering piecewise functions. Another one, this one has 3 pieces to it. So the top piece is negative absolute value of x plus 3. So I hit negative ABS. ABS is in that same math menu, I think. Let's go check it out. Math. I think you have to go over to number, and it's right there in the first option. And you enter in x plus 3. All right, the constraint is when x is less than or equal to negative 2. So I open a parenthesis, x is less than or equal to negative 2. You can see it wraps around down here. The second piece is 1/5 x cubed. All right, and that's defined when x is in between negative 2 and 1.5. All right, so that's kind of like a compound inequality, and we need to enter that in separately. So what you'll do is you'll enter in this piece right here. X is greater than or equal to negative 2, which is the same as saying this. I just kind of flipped it around. I don't even think you need to flip it around. And then you enter in the second half separately in a different set of parentheses right here. And finally, the third section is just a constant 0.7. I entered in right there, and the constraint is when x is greater than or equal to 3. All right, and if I graph it, you can see that this is the first section. This is the second section. And this is the third section, just a constant. And that would go on forever. So right now I'm going to show you how to actually enter one in from scratch. So here's my function. If you want to pause this and try to enter it yourself, that would probably be a good idea. But here we go. I'm going to go to y equals, and I'm going to say negative, in parentheses, negative 0.5x, close parentheses, open, when x is less than or equal to -1. His second math, less than or equal to is the sixth option, -1, close parenthesis. In y sub 2, I have a constant function of 2, so I'll enter that in parentheses, and then my constraint is a compound inequality. I'll put this in, this time I'll put -1 is less than, it's the fifth option, x, close parenthesis, open another one, x is less than 3, close parenthesis. And the last one is 3 times the natural log of x. So I'll close that parenthesis, close it again, open, and that's defined when x is greater than or equal to 3. That's the fourth option. Now if I graph this, I'm going to zoom 6. You'll notice that it does not look great. And it's not bad, but it doesn't look great. So what I want to do is maybe zoom in on that a little bit. So if I go zoom 2 and then I press enter, you can see that it kind of gets cut off. So what I want to do is change my window. I can't really see over here, the third piece. So I'm going to change my x max to, I don't know, 5. Let's see what happens. So there's the left hand, there's the first piece, there's the second piece, and here comes the third piece. Still can't see it. So I need to change my window a little bit more. I'm going to maybe look up. Let's go y max. Maybe I'll go up to 5. So changing windows is important when you're looking for the best possible viewing window to actually see your graph. And you can see it's over there. If I wanted to get a better idea of how the thing is curved, I might even change my x max to maybe 10 or something. So there's my linear function, there's my constant function, here comes my natural log. All right, you can, if you want to, you can change your y max again. All right, it just takes sometimes a lot of tinkering. Just get the window exactly how you want it. You could even change your x minimum over here and get a better look at it. But anyway, I hope that helped you. It's sometimes kind of annoying when you have to enter in compound inequality constraints, but for the most part, you know, these graphing calculators are pretty awesome. Over the past couple months, our school has got a bunch of new calculators in that don't have this old, you know, kind of black and white screen. They have these color screens that are more HD, and each function will graph in a different color. So those things are pretty awesome. I don't happen to have one of those on my computer, so I can't really show you that on the screen, but they do make things a lot nicer. But anyway, I hope this helped, and in the next video I'm probably going to get to some more stuff on limits. You know, how do we find the limit of a piecewise function, and we'll enter into a whole unit on limits. So thanks for watching.